Okay, so this is session 3 to 4. Now we finished the normal, production function, discussing all that in the previous videos. If you never watched it, go watch it. So now we're in a new theory, right? The neoclassical growth model now. The neoclassical growth model, right, is basically wants to emphasize that we need to invest in capital, right? We need to invest in capital. Why? Because when we invest in capital, our GDP per output or GDP per capita, same thing, GDP per person. Remember, GDP per capita is the same thing as saying GDP per person, right? Yeah. So basically, it'll increase. Now, if you look at my equation video, the last video before this, I told you how to understand equations, and this is the reason why. Because one of the equation there was change in output per person is equals to your share times the change in the capital output plus technology. Let me write it over here so you understand, but it links very good with this new classical theory. So it's your see, if it's a small letter y, that means it's output per person, also known as capital output, right? I mean output per capita. Change in y over y is equals to change in small k, remember, because this is capital per capita, capital. Plus, oh sorry, there has to be a share times the share. Times the share. The share of capital will always be theta. Plus change in technology. Change in technology will always be capital A. There's no like capita technology. Okay, so from this equation, if you actually memorize it and study it, you will know for this per capita output to grow or to grow up, one of these things have to go up, right? So if we make capital go up, right, then overall your output per person goes up. Now in economics, we deal with output per person, right, the small y. We don't deal with total output growth, the big Y, because that's saying GDP. It's not like good. Output per person gives the best standard of living, so that is why we're concerning of how to increase this. So the neoclassical growth theory basically emphasizes that, hey, listen to us. We need to somehow increase capital. But now there's a problem. We do not know how to increase capital. And there's the neoclassical growth theory comes in. So the neoclassical growth theory says, okay, for us to create more capital in the economy, so in other words, to create more capital accumulation, we need to do something. So neoclassical over there said, hey, hold on, I know how to do capital accumulation. I know how to increase the capital accumulation in the economy. We can save more. So neoclassical theory basically says if the whole economy saves more money, then we can buy more capital. Hence, we can grow our GDP per person. So that's what we say. Now, small k, whenever you see small k, right, this is capital to labor ratio. So what does it mean, right? Obviously, the higher the k, the more better. Capital labor ratio is basically like the capital to the labor. So if I have 5 machines and if I have 2 persons, right? The capital labor ratio will be this 5:2. So that means you have 5 machines, 1, 2, 3, 4, 5, and you have 2 people. Obviously, a higher capital labor ratio, this overall capital labor ratio, which is K, will be higher. It's good. That means there's more machines, more people, very good. Everyone is working those machines, good. Economy is growing up. So small K, wherever you see, is also known as a capital labor ratio, right? Just know the higher the K is, the small K is better. It's just way better, right? Now, the problem with this whole system of saving is this. Not all people are going to save continuously, right? I mean, you get one person saves, then stop saving. So the whole economy, if you really think about it, if you're going to tell everyone to save, they're not going to do it. Now this per capita output production function we looked at the previous video, very very simple. The higher the small k, the higher the capital labor ratio, the more the per capita output growth per person. Simple. Now here's all this niggery gritty stuff over here, like equations and whatnot, right? What I underline is what you need to know now. N plus dk is an equation you need to know for the investment function. For the savings function, you need to know where's this now? I saw it just now. It's S times Y. Oh yeah, it's S times Y, right? For the what other function we have? Okay, no, it's fine. So just take note of that, right? Ah, there we go. They gave the equations. So this is the equation of this function. This is the equation of this function. This is the equation of this function. Now you might be looking at this and be like, what are you trying to see? What you're trying to look at over here is what we know already. Now let me explain to you each graph so you understand what happening here. The production function, I want you to just look at and ignore all the other graphs, right? It's the same thing we said before. The higher the capital, the higher the per capita output. You see, production. So when you produce more capital labor ratio, the higher the capital output. So these are all your items you're producing in like your factories or not. Your savings function is basically how much the economy is saving. Very, very straightforward. Very straightforward. The investment function. Now this is the critical thing here. Investment function means it's what's needed in the economy, the amount of money needed in the economy for you to keep the capital labor ratio the same. So I'm like, okay, I want to pick here a capital labor ratio. Let me say this. So no matter what, I want this capital labor ratio. Let's say if this was 100, just for example. If that capital labor ratio was 100, and I want to say forever in life, I want to keep the labor ratio 100, you will need your investment requirement, which is B. So if B is 20, for example, if you keep investing 20 in the economy, 20, 20, 20, 20 every single year, no matter what, your capital labor ratio will be 100. You see what I'm saying? And for you to keep the capital labor ratio 100, you need to save 20 or whatever this amount is. Let's say this amount is 40, right? So you see what's happening over here. You're saving more than you invest. If this is 20 and this is 40, the difference is 20. So you're actually saving 20. Now, this is very important right here, right? The excess money, which is the 20. Now, I want you to think, look, I want you to emphasize this. You're saving 40 rand. The investment requirement is like spending money. So if you save 40 rand, saving 40 rand, but spending 20 rand, can you see? You have a savings or you have a surplus of 20 rand. That surplus of 20 rand over here, which you incurred, you're going to take this 20 rand and buy more capital. So as time move on, that 20 rand that comes out from here, you will buy more capital. That more capital is going to push the K to this K over here. Therefore, now everything changes. So you see how it works? So this whole neoclassical is saying, if you save more than your investment line, if you save more money than you spend, with that saving money, you can buy more capital, which will make this capital over here change to this capital labor ratio, which will obviously increase all the above, right? Now, I want you to know the link between this and the production function up over here. Right? It's very easy. Now, I want to know what am I producing at this capital labor ratio. Very simple. I look over here above, okay, it's hitting this and this. But I want to know what I'm producing. So straight from here, you go up, 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 hit the production function, mark it to the Y, small y. And that's it. So for this capital labor ratio, your per capita output per person is whatever this number is. Your saving is whatever this number is. Your investment is whatever this number is here, right? That's how this whole graph is working. Now, why do you need these equations? If you understand maths very, very easily, you can easily understand these equations, okay? For example, if if n plus d or times k, if any one of those increases, the number increases of this whole thing, right? So your graph gradient will increase. So when graph gradient increases, it goes more to the left. It like shift left. You need to know this. Past papers that tell you that shifting, what will happen to the savings function. Oh no, so what will happen to an investment requirement if you like increase n or increase d, increase population, capital. You must think about it logically. If you're increasing it, the gradient of the line is going more up. So if for example, if you increase the population, right, the n now increases. So this means the number over here will be higher. So this number or this graph will probably look something like this now. It'll shift to the left. So now, as you can see, that's what happens, right? So you must always think about that. If it lowers, it'll go to the right. Same thing with the savings function. If you save more, the saving times y. Now S is a savings rate. If they tell you the saving rate is 5%, that's 0.05. So 0.05 times small y. Small y is per capita output. They'll say it's like a million. So you'll say a million times 0.05, right? That'll give you the total of SY. So if obviously your saving rate increases, so from 0.05 it gets to 0.10, which is 0.10, obviously this graph becomes bigger. So you'll lean more towards the upper, to the left. So the savings function will look more like this now. You see, from this it went to that. So can you see how any of these graph increases, it moves to the left, right? Perfect. So you got that idea. So any of these components increase, it moves it to the left, right? Perfect. Now, to explain further into this concept, can you see all over here, you're saving more than you're investing? See where I'm circling? Sorry, putting these lines. I'm saving more I'm investing. That is why you keep on moving over here. Why? If I'm saving more than I'm investing, if I'm saving more money than I'm spending, I have extra money in my bank account. With that extra money in my bank account, I'm buying more capital. So that is the reason why, even if you're here, tomorrow you'll come over here. You're here tomorrow, you'll come the next day over here. 2 months will come over here because you keep on having extra money to spend, which is going towards a capital. Now, big problem. What's this over here? Why suddenly we stopped? Why suddenly our savings is same as investment? Why on earth now we're not losing money or spending money? We're in equilibrium. What's happening over here? Now a lot of people over here will faint, or oh wait, what happened here? Will faint or whatever, but you have to think about it logically. So let me tell you what's happening over here, right? Very simple. You see, in life, you can save, but you can't save forever. Think about it. If you got a salary of 1,000 rand, and if you start saving 100 rand every month, you start saving 100 rand, then 200, 300. When you get to 1,000 rand, can you save more? No, because you only make 1,000 rand. You get what I'm trying to say? If you have 1,000 rand, you're saving 100 rand, next month 200, then 300, 400, 5, 6, 7, 8, 9. When you go to 1,000, you can't save 1,000, 100. You can't save 1,000, 200. You can't save more money than you get. So obviously over here, there's going to be a problem. So what this problem is called? It's called steady state. Steady state. Now, when the economy reaches the steady state, or when the economy reaches this point in the economy, we don't move. We are steady. So when we steady, we'll forever produce this amount of per capita output per person. We'll forever have the savings and investment rate the same. So in this economy, this is why in the world today we have countries that just like went up so quick, produced. GDP went up, things getting good, but all of a sudden they just stopped being good, stopped growing, and all the other countries are just taking over. That's the problem. Steady state. Now, very interesting, yeah? The steady state, you might ask, so well, how do we remove the steady state? Or how do we go back or go increase now to the steady state? Well, we learned just now in other chapters that we can do it in the long run, but for now, we'll just stick to this in the neoclassical growth theory, right? So, in summary, when we get to this point, we're in steady state. Nothing is going up, nothing is going down. We're just in steady motion, right? Let's say, for instance, the country gives you 1 billion rand and suddenly, or 1 billion rand in capital, and suddenly you end up in this blue line over here. So let's say you got this K over here, and you end up over here. Can you see your saving is under your investment? So if you're saving 200 rand but you're spending 500 rand, you got a deficit. So automatically your economy will move to the steady state. So you see, so technically you move, no matter where you are, you're moving to the steady state. You see what I'm trying to say? Your steady state is where you can rest. Your economy can rest. You're not saving too much. You're not spending too much. You can rest, but it's bad because your economy is just there. It's existing. Like, you're not increasing. You're not going good. You're not, you're just there. Yeah. Now, talking about exam type questions, what they can ask you, you need to understand these equations, as I said, because they'll tell you like if n plus dk is greater than sy. That's another way of saying this black line is greater than this blue line, right? If they tell you find the equilibrium, right? Find the equilibrium. Somehow you have to basically like notice like, oh, in the equilibrium this equation is equal to this equation, because obviously the is like they're both in here, right? So you need to know this, and you'll be doing a lot of equations like that, right? Now the reason why they say yeah, yeah, so yeah, that's all you need to know for classical growth theory, right?